Hello, my name is Amy Reckhammer. I'm a PhD student at Purdue University, advised by Dr. Ming Yin, and today I will be talking about our work on using the theory of goal setting to motivate novice crowd workers in order to train them to complete complex crowdsourcing tasks. Oftentimes, crowdsourcing platforms like Amazon Mechanical Turk are associated with small, simple tasks that require basic human knowledge, known as microtasks. However, there are a variety of tasks that require more complex knowledge, such as tasks requiring specific skills that are not innate to people, or tasks requiring specific domain knowledge. Many approaches have been developed to enable the completion of complex tasks by the crowd. Some of these approaches have included decomposing complex tasks into smaller and simpler tasks that can be easily accomplished by crowd workers, and by creating teams of crowd workers that can work together using their varying skills and knowledge. A third approach, however, is by training crowd workers to complete tasks in a domain which they lack knowledge or skills. As far as we know, what has not previously been attempted within the context of crowdsourcing is motivating workers during training by setting goals, a practice studied extensively in psychology. Goal setting has been shown to be an effective strategy for motivating individuals during training to enhance learning and performance. In educational and organizational studies, the effects of goals have depended on both who sets the goal and the type of goal, with common goal types being performance goals, learning goals, and behavioral goals. Performance goals specify the targeted end results of learning. Learning goals state the range of skills and knowledge that the learner aims to master upon completion of training. And behavioral goals describe a set of behaviors that the learner should follow during the training process. Additionally, prior literature has shown that the most effective goals are specific and difficult, but not impossible to achieve. While setting goals has had merit in traditional educational environments, the effects in the context of crowdsourcing are unclear, though the underlying idea of setting a goal to provide motivation during training holds. Many differences between the traditional environment of a classroom or workplace and the online crowdsourcing environment exist that could lead to differing results. In this paper, we test the theory of goal setting in the context of crowdsourcing by exploring how goal setting can affect crowd workers' learning during training for complex tasks and their perceptions and performance after training. In this study, our two main research questions then were, how does setting different goals affect workers' learning perceptions during training, and how does setting different goals affect workers' learning gain during training and performance on tasks after training? In addition to these main questions, we conducted exploratory analysis to examine when and why different goals work or do not work in influencing workers' learning and performance. In our study, we chose the nutrition analysis task as the complex task that we would train crowd workers to complete. Specifically, the task asked workers to look at images of 2 meals and a list of the 2 meals' ingredients to decide which of the meals contains more of a specified nutritional component, which was either fat, fiber, protein, or carbohydrates. The example task shown on the left here asks workers to decide which meal has more protein, a peanut butter and jelly sandwich, or a bagel with kale, red peppers, bacon, and cream cheese. Workers that we recruited from Amazon Mechanical Turk completed a total of 3 hits for our study. A diagram of the first hit is displayed here. Workers started off by completing 12 pre-test tasks, where the task was the nutrition task detailed in the previous slide. The number of tasks that workers answered correctly in the pre-test was used to measure performance on the task before going through training. The next portion was the goal setting, which was treatment dependent and will be explained on the next slide. Workers then went through a set of lessons in the training phase to provide them with knowledge to help on the nutrition tasks. They were provided with both written instruction and videos about each of the 4 nutritional components, and at the bottom of each component's page, a multiple choice question was asked about the content of that page. Workers could not move on from the nutrition lessons until they had visited the lesson for each nutritional component and had answered all 4 questions correctly. From there, workers could complete up to 10 optional practice tasks, either by choosing to move on partway through completing the practice tasks or by bypassing them altogether. Answers with explanation were shown to workers after each practice task that they completed. Upon either completing the practice tasks or deciding to move on, they took a 2-part survey. The first part asked workers questions about their perceptions of the nutrition lessons, specifically asking how helpful they found the lessons and how much they feel they learned from the lessons using a Likert scale. We considered the answers to these questions to be a worker's learning perceptions. The second part of the survey asked questions relating to workers' goal orientation, which we adapted from an existing survey. Goal orientation relates to the factors that best motivate a person, with this survey determining if the worker was more motivated to perform well on tasks, known as performance goal orientation, or to learn new things, known as learning goal orientation. Finally, workers completed 12 post-test nutrition tasks and then a quick demographics survey. By taking the difference between the number of nutrition tasks that the worker answered correctly in the pre-test versus the post-test, we created a quantitative representation of the worker's learning gain from the lessons. Throughout the next week, workers were invited to complete 2 more hits, and each hit had 12 more nutrition tasks that the worker had not seen before. The number of tasks answered correctly on these 2 subsequent hits represent workers' post-training performance in our analysis. In the goal-setting portion of the experimental procedure, we varied whether and how goals were set for workers by considering an experimental design along 2 factors: the initiator of the goal, which was who set the goal, and the type of goal. There were 2 types of initiators, either the worker themselves or the requester. In addition, there were 3 types of goals that were meant to model the most common goal types in traditional literature: a performance goal, which specified the number of questions that the worker aimed to answer correctly on the post-test nutrition tasks, a learning goal, which specified the knowledge that the worker aimed to learn from the nutrition lessons, and a practice goal, which is an operationalization of the behavioral goal and specified the number of practice tasks that the worker aimed to complete after the nutrition lessons. There was also a control treatment, where the worker did not have a goal. Altogether, this led to 7 treatments. Now let's take a look at what we have observed from our study. First, we note that the nutrition task was difficult for our crowd workers. In the pre-test, which recall is meant to measure workers' knowledge and skill in the task before going through training, the average number of tasks correctly answered was 8.5 out of 12, which is roughly 71%. Additionally, 11% of our workers answered no more than 6 pre-test tasks correctly out of 12. Since the nutrition task asks workers to choose between only 2 options, this means that this 11% of workers were able to perform the task no better, if not worse, than just random guessing. This provides support that this is a complex task that requires specific domain knowledge in order to perform well, domain knowledge that many lay people lack. Observing the goals that workers set for themselves, we found that many workers who were asked to set learning goals set meaningful goals. Such examples of meaningful goals include, I want to learn more about fat content in food, and I'd like to learn which foods likely don't have gluten but also have high fiber. However, for workers asked to set practice goals, many purposefully chose not to challenge themselves by setting a goal that was very easy to achieve. On average, workers in this treatment aimed to complete 4.3 out of 10 possible practice tasks. To answer our main research questions, we start by looking at how setting different goals affected workers' learning perceptions during training. Recall that we measured learning perceptions through survey questions, asking workers how helpful they believed the nutrition lessons to be, and how much they believed they learned from the nutrition lessons. As the result of a Novice test that we conducted to analyze the effect that different goal treatments had on learning perceptions, we found that workers with a learning goal reported the nutrition lessons as being significantly more helpful than workers with the other types of goals. Workers with a learning goal also perceived themselves as having learned significantly more from the nutrition lessons. The initiator of the goal did not have a significant effect. We performed similar analysis to explore our second research question, which was how setting different goals affects workers' learning gain during training and performance on tasks after training. In doing so, we found no evidence that setting goals led to increased learning gain or post-training performance. Since the result of our main analysis differs from prior studies on goal setting, namely that goal setting does not lead to a difference in learning or performance, we chose to conduct exploratory analysis to examine when goals do work in improving learning and performance, and why they do not work when analyzing our full population of workers. Prior literature has found that matching a goal type with a person's goal orientation can lead to improved performance. and since we collected survey responses from workers relating to their goal orientation, we were able to explore the question, does setting a goal for workers that matches with their goal orientation lead to higher levels of learning gain and post-training performance? Additionally, many prior studies have shown that behavioral goals, in particular, can lead to improved learning and performance. And if behavioral goals can lead to increased adoption of the specified behavior, then this finding would be intuitive given the benefits of practice towards improvement in almost any domain. However, in our main analysis, we did not find that having a practice goal leads to higher learning gain or performance, prompting us to explore the following question: does setting a practice goal lead to more practice tasks being completed? And does completing more practice tasks associate with higher levels of learning gain and post-training performance? When exploring the effect of matching a worker's goal type with their goal orientation, we repeated our main analyses separately for the subset of workers with high performance goal orientation, as well as the subset of workers with high learning goal orientation. We determined these subsets of workers by taking those who had the top 50% of scores for each set of orientation survey questions. Although we found no evidence that matching using a performance goal improves learning gain or post-training performance, we did find that matching a learning goal to workers who are highly oriented for learning improves learning gain, but has no effect on post-training performance. This provides evidence of the matching effect between goal type and goal orientation seen in prior goal-setting studies. We now move on to exploring whether or not behavioral goals actually have an effect in crowdsourcing environments. To do so, we first look at whether having a practice goal influenced workers to complete more practice tasks. For those workers that were given a practice goal by the requester, significantly more practice tasks were completed on average than in other treatments, but the same cannot be said for workers asked to set their own practice goal. Recall that workers asked to set their own practice goal typically set a relatively easy goal for themselves, with an average of 4.3 out of 10 practice tasks that they aim to complete. Next, we look at the relationship between the number of practice tasks completed and learning gain and performance. Surprisingly, we found among our workers a positive correlation between completing more practice tasks and having higher learning gain and post-training performance. Since we did not find in our main analyses that workers in any goal treatment had significantly higher learning gain or performance, you may be wondering where the disconnect is here. Looking closer into this finding, we found that for the workers with a requester set practice goal, their learning gain and post-training performance was lower than workers in other treatments who also completed many practice tasks, suggesting that workers who engaged in the behavior of their own volition reaped greater benefits from it. We conjecture that the workers in the requester set practice goal treatment chose to satisfice, allowing them to meet their goal even if they did not receive the desired benefits from it. Since we found that our results differed from those of typical goal-setting studies, we begin our discussion with differences between the crowdsourcing environment and typical goal-setting environments that may have contributed to these discrepancies. First, crowdsourcing tasks on platforms such as Amazon Mechanical Turk are done anonymously, remotely, and typically for a short duration of time. This is in direct contrast to typical workplace and classroom environments where goal-setting studies are usually held, and where those taking part in the study are held accountable for their work and have made a commitment to it for a longer period of time. In crowdsourcing environments, however, the anonymity that workers enjoy make the stakes lower should the worker choose to drop out of a task or put little effort into it, and the short-term contract between the worker and requester means that the time frame may be too short for the effects of goal setting to be noticeable. Additionally, the outcome of the performance for workers and students in traditional goal-setting environments is of greater importance to them than the crowd workers in our study. We did not include any external incentives in our hits for good performance, since the theory of goal setting revolves around the goals themselves being the source of motivation. But even though this may also be the case for traditional studies, external incentive is inherent in good performance in classroom and workplace settings. For students taking a class, good performance translates to a good grade, higher GPA, and better job prospects. And for workers in a traditional workplace, good performance can be required for keeping their job or for being considered for a promotion. Without an external incentive, such as increased payment or the promise of additional work, some of our workers may not have had the motivation to commit to their goal. We now conclude with two practical implications from our study for setting goals when training crowd workers. The first is that the increased benefit of matching workers with high learning goal orientation with a learning goal suggests that additional studies should be done to further explore ways to personalize goals for workers in order to see greater benefits from training. Simply recruiting a random set of workers and setting some goal for them may not be effective, and instead the right type of goal may need to be set in the right way for the right workers. The second implication comes from our finding that the requester set practice goal led to greater adoption of practice tasks, although completing more practice tasks only led to improved performance when the worker made the decision themselves to complete them. This indicates that behavioral goals do increase adoption of desired behavior, but future work still needs to be done to discover how to make workers see the merit of this desired behavior so that they do not feel forced to adopt it. One possible way to do this is to communicate the benefits of the desired behavior more explicitly so that workers understand that the behavior is worthwhile. Thank you for taking the time to listen to my talk. If you're interested, I encourage you to read our paper in the HCOMP 2020 proceedings.